Earthquakes. Now that we know about faults, we can finally look at earthquakes because earthquakes occur on fault lines. So as you look at these different pictures, you can see some of the destruction that's created by earthquakes. I like to point out the picture up here at the top. Those are not clouds, that's smoke. Because one thing that earthquakes can create are fires due to ruptured gas lines. And then I wanted to point out these pictures right over here, because you can see as there were movement on the fault, this could have been a reverse fault where the hanging wall moved up, but you can see how there is a complete change in the elevation, and sometimes that's very drastic, sometimes it's not. But we're going to look at what causes earthquakes and some different aspects about them. So let's get started. Okay, so your first thing is, what is an earthquake? Well, all that an earthquake is vibration released from the earth. And yes, this is all bolded, so you do need to write all of it down. So when you have an earthquake, the earth is literally vibrating, it's shaking, and what's causing that vibration or that shaking is this energy that was stored up within the earth that got released. And as those energy waves move through the ground, making their way to the surface, that's what's shaking the ground, creating that earthquake. Where is this energy being stored up? Well, the energy is being stored up on fault lines. So you have faults because you have all of our plates that are constantly trying to move. And as they try to move, they're building up energy because they can't just slide past one another. There's way too much friction for that. They are slowly and surely pushing and pushing and pushing against one another until eventually there's so much energy that it can't stay still anymore. It has to move, and it will break parts of the earth and move forward very, very quickly. And those are on the fault lines, and that's what we feel as the earthquake. So as you finish writing that down, if you look at the picture of the globe down here, you can see the plate tectonic boundaries. Again, I've already mentioned this before, but plate boundaries are not necessarily in line with countries. They don't follow like pretty borders. Our countries are within the plate boundaries. So this shows you a good diagram of them. There is a boundary right along the coast of California. It's a transform boundary that creates a bunch of little faults. And so if you look like right here, you have a line and then you have lots of little lines coming out from it. Those little lines are showing you the faults. The main line is your plate boundary, and then because it's moving, it's fractured or cracked lots of little pieces of rock off to the side. And that's what we call the fault line. So as those plates are trying to move, your faults are taking in some of that movement and trying to move, but they can't until energy is stronger than the rock. And then the rock breaks, it moves, and we feel an earthquake. And then hopefully disasters like this don't happen, because that would not be fun. And also another reminder, a capital E means energy. So anytime you see a capital E, that means energy. It's just to help you write faster, but also so I don't have to write as much on each slide. So let's move on to our next one. So focus and epicenter. We know that the earthquake is going to occur within a fault line. Well, the focus, and I would recommend drawing this. You can just draw a box representing the earth, kind of like the box that's down here. Remember, fault lines, you don't have to draw the fault, but if you want to, you can. But the focus is the point inside the earth, okay, inside the earth. This is where the actual earthquake is occurring. So I shouldn't use that color. Let's switch to red. Focus. So the focus is the point actually inside of the earth where the earthquake is occurring. If you look at this actual computer diagram, you can see those little waves coming out. Those are the energy waves, or those vibration waves that are being released, and they're traveling to the surface. So the focus is in the earth, and then directly above the focus is what we call the epicenter. This epicenter is going to be within, on the surface of the earth. So this is like where your house would be. So you have the focus inside the earth, and then you have the epicenter directly above it on the surface. This is a very, very common type of test question. I would not be surprised if you saw me give you something like this at all. They want you to be able to identify that the focus is inside the earth while the epicenter is outside the earth. The actual movement of the rock is occurring with where the focus is, and those waves are coming out and they hit us and we feel it on the surface at the epicenter. Okay, so those are just two things you're going to have to make sure that you don't get confused. That might involve you memorizing them. One little memory trick that I've heard before is the epicenter. So if you are the center of attention, you want to be seen by everyone. So the epicenter is on the surface because it can be seen by everyone. So it's the center of attention where everybody can see it, and the surface is where that occurs. So I'll go ahead and clear the screen, and we'll move on to the next one. So elastic rebound hypothesis. This is just saying that as the faults are trying to move, they're trying to slide past one another, but unable to do so gracefully, they build up a lot of energy. And eventually, that energy is stronger than the material, and so it snaps, creating the movement and the vibration of the earthquake. Imagine if you have a rubber band, and you are pulling it and stretching it, and stretching and stretching and stretching it. Well, eventually, you're going to stretch that rubber band so much that the tension you're putting on the rubber band is stronger than the rubber itself. And so that causes that rubber to break, and it's going to slap back, and it's going to hit your hand, and it's probably going to sting. So you get the rubber band, you pull, and when the tension exceeds the strength of the rubber band, it breaks, and and it swings back, releasing the energy. That's what this is talking about. As your plates are trying to move, you can imagine they're trying and trying and trying, but they can't, but that energy is still there. And then eventually that energy is stronger than what the rock is. And so it breaks the rock and it slides forward really fast. And that is what causes the actual earthquake. That's what that bottom bullet is trying to talk about. So that is the elastic rebound hypothesis. That's really not that much to write. So hopefully you're done writing this down. And I can move on. I can wait just a second, just in case. And sorry that little thing down at the bottom won't go away. I can't figure it out, but it's not hurting anything. Okay, hopefully you're done writing by now. If not, you're going very slow. So, foreshock versus aftershock. These are two terms you've probably heard of before. Foreshock comes before the earthquake, foreshock before, and aftershock comes after the earthquake. Now, this is only when you have your really major, huge earthquakes, not the little tiny minor ones. Earthquakes can range from a lot of different intensities. So you could have an earthquake where the ground moved and maybe one person felt it, but someone else didn't even feel it at all because it was such a minor little tremble. Versus such a large earthquake that it, crushed buildings and moved the roads and caused fires. So they can be very, very different. The foreshock and aftershock only takes place when you have those really, really large ones. So it will be before your big major earthquake. You have a little bit of a tremble. That's this foreshock. It's a very small earthquake. And that's probably enough. That's why people get scared sometimes when you have a small earthquake, because what they wonder is if that means a bigger one is coming. So you have a small little tremble in the ground, shaking, and then a little while later you'll have this giant earthquake. And then after the giant earthquake happens, that's when you can get your aftershocks. And you can have multiple aftershocks. It doesn't just have to be one. So it'll just be a little tiny tremble here and there that doesn't last long. But the scary thing about aftershocks, because they are so small, is you've already had a major earthquake. And so this major earthquake has already weakened the structures of buildings and things like that. So once these little aftershocks come, that could be the movement that is just like the final straw and can cause that building to come completely tumbling down, which is what makes the aftershock also scary. But again, that's only with your major earthquakes. So that's foreshock and aftershock. Okay, so let's move on. If you aren't done writing, y'all can pause for a second to finish, but I don't know what else to say. So I'm going to the next slide. San Andreas Fault. This is a video that I would like to show you. So I'll let you go ahead and pause the video and switch to this other video, and then after that we will have a brain break. So hang in there and make sure you pay attention, because the video that you're about to watch is going to put together a lot of the stuff that we just talked about. Okay, so here is your brain break. Everybody get your hands, put them together with just your fingertips touching, and then get your middle finger knuckles, bend them down, and connect them like you see in this picture over here. So you put your fingertips together and you put your middle finger knuckles together. And so I've got a front picture and a side view of what that looks like. Now, this is the hard part. Move your thumb, separate your thumbs, put them back together. Separate your pointer fingers, put them back together. And then try to separate your ring fingers without moving those middle knuckles, and see if you can do that. Some people get super excited because they're like, oh look, I did it. But these middle knuckles have moved up and are separated. Those top two knuckles need to stay flat. So go ahead and try that out and see if you can do it. And you can pause the video while you try. I know we've already covered quite a bit of vocabulary and terms, but here are a couple more. So seismology is the study of earthquake waves. Remember, anytime we talk about an ology, we're talking about a study. So you have geology, biology. That's simply meaning the study of something. So when we are looking at seismology, we are looking at the study of seismic waves. So seismology, that's all that it's trying to get at. So seismology is the study of earthquake waves. There are two things that you look at when you are studying seismology. Well, one, you use a tool or an instrument called a seismograph. I have two pictures of seismographs to the right that you can look at. But think about how when you're in math class, you use a graphing calculator. And the graphing calculator is the tool that you are using. So the seismograph is the tool or the instrument that you use. The seismogram is the recording made based off of that. Whoops, I meant to say tool, not took. The tool. So seismogram is the writing or picture that's made from it. I don't know if any of you have ever heard of like a candygram, but typically if you get a candygram, they're usually done around like Valentine's Day. You have people that come around and they'll sing a little message. And so that message is what the gram is, and they give you some candy with it. So when you're looking at gram, you're looking at a written part or a message. So the seismogram is the record or the recording created by the seismograph. So seismology is the study of the earthquake waves. The seismograph is the tool you're using to study those waves, and the seismogram is the recording of those waves. So the way that a seismograph works, this kind down here, is you have this very heavy ball that's dangling down or suspended in the air. And so when the ground shakes, because this is suspended in the air, it does not move. And so you could think about if this is the ball that's suspended in the air, it has a little piece of lead that is coming down from it, a little point of lead. And so as that's connected to some paper. And so as the ground shakes from the earthquake, the table will move, but that suspended ball will not move. And so it will end up drawing a recording that looks something like this. So here is the major earthquake happening, and then you have your foreshock over here and your aftershock over there. But again, the actual suspended ball in the air does not move. That has to do with physics, but the table around it will, and that is what gives you that seismogram or that squiggly looking line that kind of looks like the heartbeat thing you would see in a hospital. So those are your 3 new vocabulary words. Go ahead and finish writing those down. If you need to pause the video, go for it. But I'm going to go to the next slide. If you are still confused on how a seismograph works, or you're just more interested to learn about it, then you can watch this video link here. Because remember, the notes are always on Canvas, so you can go back and you can watch this if you just want to learn a little bit more about it. Earthquake waves. We have 2 types of earthquake waves. The first type of earthquake wave is a surface wave. So this is the first type of earthquake wave. The next slide is going to have 2. So with earthquake waves, we have 2 kinds. First kind is the surface waves. Well, guess where surface waves occur? On the surface. Wow, who would have put that together? Thankfully, this is one of those things where scientists named it in a way that makes sense. So surface waves occur on the surface, and they are the most destructive of all the earthquake waves. Now, this makes sense because if you are looking at destruction from an earthquake, and we're looking at buildings and whatnot that have collapsed, then those are all on the surface. So with these waves get to the surface, to the epicenter of the earthquake, these waves are moving up and down and side to side. So they're kind of rolling and then moving side to side like a snake. And if you can picture the ground doing that type of a movement, then you could imagine the damage that it's going to do to buildings and structures that are around. And in a little bit, I'm going to show y'all some actual videos of earthquakes occurring. And you can see how the ground is moving like that. And in some of the videos, you'll even see the ground cracking. So those are kind of interesting to see. But that is your earthquake waves, the surface ones. Now we are going to look at our second type of earthquake wave. If I can clear the screen. There we go. So we had surface. Now we're looking at body waves. So body waves are the second type of earthquake waves. However, there are 2 kinds of body waves. So if I ask you, what are the 2 types of earthquake waves, you're going to say surface and body waves. If I ask you what are the 2 types of body waves, you would say P waves and S waves. Make sure you have that clear. The 2 types of earthquake waves are body and surface, and the 2 types of body waves are the P and the S waves. So let's look at our first body wave, which is a P wave. P waves push and pull. Okay, they push and they pull, and that is kind of obvious by what it's called, a P wave, push, pull. It all starts with a P. And they travel through solids, liquids, and gas. So P waves travel through everything. So they can push and pull, do that motion kind of like a slinky. They can send that type of wave out that will move through liquids, it will move through gas, and it will move through a solid. So that is the first of your body waves that push and pull. And I'll give you a second. Clear the screen. Okay, and now let's look at our S wave. Just like a P wave is named kind of a common sense wave with push and pull, S wave is also named in a way that makes sense. So S waves, again, are a type of body wave, and they shake. So this would be kind of like a snake slithering, kind of like your surface wave, but this is going to be a little bit different. So your S wave is shaking particles at right angles, and they only travel through solids. So this also is kind of easy to remember because you have S waves, shake, and solids. So they're very, very, it's named in a way that just will help you remember it. So that your 2 types of earthquake waves are body and surface. The 2 types of body waves are P waves and S waves. P waves push and pull, and they can travel through all materials. S waves shake and only travel through solids. And hopefully that makes sense. And again, there's so much vocabulary and so much in this unit with the boundaries and stuff. You're gonna have to make sure you study this and that you look over it. Make sure you're taking your study guide seriously, as you always should, but especially with this unit because there's just so much material. Now, I have a video that I'm going to let y'all switch to in just a moment, and I just want to go ahead and put this out there. The professor in this video is extremely handsome, and I get that, but there's always a group of girls that just feel the need to talk about how good looking he is through the whole video. Go ahead, when the video starts, admire him, but then just be quiet so that way you can actually see the demonstration that he is doing, and that way we can all learn a little bit more about the P and S wave. So I will let you pause this video while you switch over to the other one.